Okay, perfect. So, hi everyone. My name is Pierre Zemb, and I will be speaking about our experience using Apache Pulsar to create a messaging solution for OVHcloud. So the goal of this talk is really to give you insights of what we did, what went wrong, and all the things that we learned, so that we hope it will help you getting started with Apache Pulsar. Let me just up. So my name is Pierre Zemb, and I'm working at OVHcloud. We are a cloud provider. I will be speaking a bit about it later. And I'm working mostly around distributed systems. So I have experience developing and operating things like Apache Hadoop, HBase, Flink, Kafka, Zookeeper, and now of course Pulsar. I do have some contributions to some of them, and I'm living in France, in Brest, and I'm also involved into local developer communities, such as the Java user group, the Google developer group, the DevOps for Kids, and Developer Festival. So here's our schedule. I will just briefly talk about my company and then why we needed the messaging solution, why we chose Pulsar as the foundation of it. I will go briefly over our infrastructure, our management layer, and I will be speaking about the quest to support Apache Kafka, because that was one of the main work that we did. And then I will be answering some questions. So OVHcloud, for those who don't know, we are a cloud provider. In fact, we are the biggest European one. We have around 30 data centers across the world with our own global network. If you are interested into alternative cloud provider, just feel free to check us out. And within OVH, I'm working around public cloud universe and behind the idea of offering platforms to our customers. So if you think about computing platform, we are mainly offering two in public cloud. The first one is OpenStack, of course. And the second one is Kubernetes. And this one is kind of interesting for VHcloud because we are more, let's say, well known for being an infrastructure provider, meaning that we are offering virtual machines, bare metal servers, domain, and many services, but we do not have a lot of developer-oriented products. And this one, the Managed Kubernetes, was one of the first one. And thanks to it, we have now more and more developers that are aware of VHcloud and are using it, our infrastructure. And they are starting to deploy their microservices into Kubernetes. And they were asking for us, okay, now I have my pods running. Do you have some kind of messaging solutions? Can I have some managed Kafka or managed RabbitMQ or managed NATs? Do you have this kind of thing? And we thought, okay, that is a good idea. Let's just build a messaging solution. And the interesting part is that we already did something like this. So it was called queue as a service, and it was opened as a beta in 2015. It was heavily based on Apache Kafka. So we were using one cluster in a multi-tenant way. But this multi-tenant cluster was kind of difficult to handle, so we decided to close the beta in 2018. Nevertheless, the code is still massively used internally. And from this beta, we can learn a lot of things, both from our users and from us. So let's just start from our users. So this is like a short list of things that our customers wanted, but they were saying, okay, you have Kafka, so this is cool, but I just want also some queuing, and RabbitMQ is a good choice, MQTT, and now NATS is also on the game. So I just want to use multiple queue or streaming services. Also in 2015, if you were a Kafka user at that time, there was this breaking change between 0.8 and 0.9, and a lot of customers ask us to support all versions of Kafka protocols to avoid upgrading their code. So that was something that they wanted, and there was this thing of data encryption. So they wanted us to handle this, the data encryption on the fly. So that's a bit of the checklist from our users. And now let's go on our side. So we learned a lot of things running Apache Kafka on thousands and thousands of topics. And there was like this list of things that was complicated for us. So the first one is there is no multi-tenancy and geo-replication built in Apache Kafka. So as you can imagine, from a cloud provider, multi-tenancy offering a topic, we have to have a multi-tenancy built in. And geo-replication is always possible on the client side, but it's better if it's handled directly by the platform. So that's the first point. Second thing is that as we were adding more and more customers on our Kafka cluster, creating a topic was starting to be not cost-free, and it was like difficult for us to have this capacity planning and stuff like that. One thing that is not possible also with Apache Kafka, or difficult, is to have infinite retention. For example, or a year of retention, for example, is easy. You can just say, okay, I want a year of retention. But if you want infinite, you just have to do this hacky, I need 100 years of retention. Also, there is no tiered storage, so you cannot offload data on S3, for example. And operations are not very convenient at the scale that we reached, because it's not that easy to just scale the storage system. As the broker is handling the messaging and the storage, you cannot just scale one side of it. So that was problematic for us. And there was one part that was bothering us too, that's the fact that Apache Kafka is heavily using the cache. So if you have a consumer that is reading all data, you can slow down the whole broker because you will heavily using the cache inside. So yes, I did a list of all the things that was difficult for us for Apache Kafka, but I want just to say this first. We love Apache Kafka. We have far more messages in Kafka than Pulsar within OVHcloud. We have millions of them per second. I just want to highlight the fact that for certain use cases or for certain needs, we need an alternative for Apache Kafka. So we wanted to build a messaging solutions, and we like to divide the solution in two. So at the bottom, we have what we choose as an infrastructure provider. So we want something that scales well, that is operating with operations that are quite easy. And we want also to have separation and expose other things. So we want to have this Pulsar endpoint, this Kafka endpoint, this RabbitMQ endpoint, which is kind of decorrelate of our messaging systems. So we need to find something that will be at the bottom of our messaging solution. So we have some requirements. So of course it must have multi-tenancy. We want it to be used for queuing and streaming. As we will deeply extend the messaging solution, it needs to be easily extendable, and we want the whole solution to have lower operation cost at scale. So this was like our requirements. We search, we test things, and obviously because I'm here, you must have guessed that we are using Apache Pulsar. I will just go briefly on the too long didn't read good part of Apache Pulsar. So you have this, you have multi-tenancy, you have security, you have authentication, authorization. There is geo-replication directly. You can have queuing and streaming semantics. There is this tiered storage that is really interesting also. You have schema and integration with big data ecosystem, so Flink, Spark, Presto. So this is like the good part of Apache Pulsar. So let's deploy it. Our deployment is kind of simple. Okay, let me just try to remove this. I cannot move this one. Okay, so never mind. So everything is deployed on bare metal servers within OVHcloud. We are using Apache in as the front end of one cluster. And after Apache, we are within a private network. So the first component that you'll be hitting is the Pulsar proxy. So this component is designed to avoid exposing brokers directly to the internet. So it's really nice for us to have this proxy before arriving on the broker. So we have this proxy, which is a component of the regular Apache Pulsar distribution. Then we have our brokers, and then we have the Bookkeeper part with Zookeeper, of course. So everything is metrics based on the monitoring part. If you have questions about the metrics, I will be happy to answer them at the end. So let's start at what we did that will not be maybe common. So let's start with Bookkeeper. So Bookkeeper is the storage layer. We enable something that is called ZGC on it. I think that is pretty experimental, but ZGC is a new garbage collector. I think it's still flagged as experimental, but we have tested with G1, and we have far more better performances with ZGC. with just a little CPU overhead, so that's really nice. So it's working on Bookkeeper and not on Pulsar, so be careful when you are enabling ZGC everywhere. As I said before, we are heavy metrics users, so we are using the Prometheus exporter. And then on the Bookkeeper configuration, we mapped the profile of our dedicated machines. So for each Bookkeeper machines, we have two SSDs. So one for the OS and one for the journals. The journals are kind of the wall, and they are hard drive optimized. So we decided to have multiple journal directories to better exploit the SSD throughput. And then, so that's the SSD configuration. And then we have 4 hard drives per Bookkeeper. And we are just putting 1 ledger directory per hard drive. So that was the Bookkeeper configuration. Let's go higher on the stack and see the Pulsar configuration. So we started with a configuration that is 3.3.2. So when you are configuring Pulsar, you need to choose the guarantee of writing. So there is these three parameters. So the first one is the ensemble. It's the number of bookies that you are going to use when you are creating a ledger on Bookkeeper. So we started with 3. Then we have the write quorum, which is how many copies of the message you will be storing at the same time. So we started with 3. And then we have the acquittement quorum. So how many counted copies before responding, okay, we definitely write this thing. So we started with 3.3.2, and at the beginning we had only 3 bookies, so 3 Bookkeeper machines, and that was kind of difficult. We hit some issues when we are deleting, reinstalling one machine. So first lesson that we learned: never have the ensemble equals to the number of bookies. So we kind of changed the layout and we added more machines. So we are now running a 4.2.2 layout, which which allow for more stripped writes across the bookies. So let's, after we set up this thing, we decided to do some non-repeatable benchmark. So I will share with you the hardware that we are using, but we did something. We wanted to see how far we could go with our configuration. So we were our benchmark was quite simple. We were sending a small string, which was hello Pulsar, as value as fast as we can from async producers from 8 virtual machines to a partition topic with 2 partitions. And we were really happy to see that we reached 1.8 millions of messages per second per partitions. You can see there is 2 time series here. So we were like very happy, and we were adding these other virtual machines, and then, as you can see, something went wrong here. And the truth is, we had this Bookkeeper outage. That was the beginning of the cluster, and we had some misconfiguration file. We did a mistake on Ansible, and everything went down. And we were like, okay, this is the first outage that we are taking. We need to find the root cause and fix it. So the second lesson we learned is that if you are if you really want to operate Apache Pulsar, I really recommend that you are familiar with the Bookkeeper command line interface. So, for example, here I can list all the bookies that are in read and write. So it's really nice to see which bookies are live. There is another command which is really nice, which is simple test, that is trying to create a ledger on the cluster. And this one is, you should be using that one to test that everything is working again on your cluster. There is one actor which is really important in Bookkeeper, which is the Auditor. The Auditor is a selected actor which will be taking care of replication and repair ledger. So this is really your best friend in case of outage. You can easily retrieve who is the auditor on your cluster by running the whoisAuditor command. And then you can check on the log. So it's kind of blurry, but it says, okay, I need to audit all the bookies that I have. Here's my machine that has failed, and it was holding this ledger. So I will identify them as under-replicated, and then it will start replicating stuff. So if everything goes smoothly, you will see this, that the ledger are kind of replicated successfully. So yeah, lesson learned, just play with Bookkeeper before starting the Pulsar way. So that was kind of our infrastructure part. So let's manage now Apache Pulsar. So we have created a management layer, which is microservices, which is taking, which is receiving create all the commands that you are that we want to do. So when you are creating a topic, when you are creating tokens, when you are setting retention, you are going through these microservices, and then the microservices will sync this state across Apache Pulsar clusters. So our management layer is written in Go. It is cluster aware, meaning that we can just add a new cluster and it will be able to create things on it. It has a push-pull design base. So we are pushing topics configuration to clusters, and we are pulling topics usage from cluster. And also it's responsible for the generate valid JOTS tokens. And there is another lesson here that we have, is that pulling topic usage is kind of costly. I think we should maybe design a Pulsar improvement proposal to find a way to report them, so that our management layer should just subscribe to a topic that will be used. That would be far more cost efficient than just, pulling every second or so the topic usage. A bit of words on how we handle the tenancy. So if you don't know, geo-replication, tiered storage, retention, and other configuration are on the namespace level. They are not something that you can define on a topic level. So a namespace is a group of topics, basically. So we ended up doing something that the community is doing a lot. So we are mapping topics to namespaces, which results of using one namespace per topic, which is not kind of efficient. So we have here our tenant, and then we have the namespace, which is the name of the topic, and after our topic. So we kind of break the namespace usage. And to enforce this behavior, this is one of the main reasons that we had to close the admin API to our customers. But as always, there is hope. There is the Pulsar improvement proposal 39, which will allow us to have configuration on the topic level. So we are looking forward for this improvement proposal. And another lesson that we learned is that as we close the admin API from our users, we need to rewrite all calls only to forward them, which is really costly on our side. So we hope that using the improvement proposal 39 and having a way to report cluster usage will allow us to open back the admin API for our customers. So we did some, we talked about deployment, we talked about management. So we could open our beta. So it's called ioStream. So now we have a messaging solutions. We have a messaging solutions, and in fact, we have a messaging system. So we are using Pulsar at the bottom, but you see this empty space just above Pulsar. Remember, we want to have this. So we have Pulsar at the bottom, but we wanted more. So we decided to work towards Kafka compatibility in Pulsar. So there is a whole talk that we did with CJ yesterday. If you are interested into Kafka on Pulsar, just check it out. I will just go briefly on those slides. So we decided to implement this functionality as a proxy first. So we wrote a proxy in Rust because we wanted to avoid garbage collection on proxy layers. And Rust have awesome libraries to work at the TCP level. So our main goal was to convert or translate TCP frames from Kafka to TCP frames from Pulsar. So it was like translating Kafka protocols into Pulsar. So it will have looked like this. We have Kafka clients on the left, Pulsar on the right, and we have our magical proxy layer, which is called Hyperion, on the middle. And as we were emulating Kafka broker, we were concerned about the safety of the protocol. So we decided to implement the connections as a state machine, so as a finite state machines. So each state machines are event-driven with which were triggered by TCP frames from their respective protocol. And we had a third one to provide synchronization. So in other words, we have a connection from Kafka clients, and when Kafka clients are sending things, the state machine will just move around to handle stuff. We have another state machines that is handling the Pulsar connection as well. And when we need to go across them, we are using a third one that is providing synchronization. So for example, if you are producing stuff, we are assuring that the state machine on the right is capable of sending a message, and the state machine on the left is asking to produce a message. So this was really funny to write this proxy because it was blazing fast because working at TCP layers enable performances. It was a nice proof of concept to discover both protocols. Rust is blazing fast. You should test it if you are looking for another programming language. We learned that proxify production is kind of easy, is relatively easy. And one thing that was interesting with our proxy is that we could bump all versions of Kafka frames for all Kafka clients. And the bad part of our proxy is that we just rewrote everything from the Kafka client to the Pulsar client. It was heavy work. And we learned that there's things that are really hard to proxify, and in fact, it's everything that is consuming related. So that's the group coordinator and the offsets management. And we were kind of preoccupied by the fact that it could have been difficult to open source because many of the main components of Apache Pulsar are written in Java. So we were like, this could be difficult to give back to the community. So we were kind of struggling with writing the code that we were kind of, stuck on our proxy. And then we saw this amazing tweet from Stream Native, which was saying, we are working on Kafka and Pulsar. We are adding the Kafka protocols directly to the broker. And that was just it. Adding Kafka was a good idea, but doing it on the proxy layer was difficult. And the Stream Native guys saw that, and they implemented directly on the broker. And we contacted them, and we worked directly on their work. And we announced Kafka on Pulsar a few months ago. So how does it work? I will go quickly. This is like Apache Pulsar view. So you have the Pulsar protocol handler here. And now you can just load any other protocol directly inside the broker, meaning that you have access to internal stuff of a Pulsar topic, which are kind of handy when you want to simulate consumer group, for example. So we have now Pulsar, which is capable of speaking Kafka, but the Stream Native guys are working also on AMQP on Pulsar. So this is another protocol handler, which is available on GitHub. I didn't have the time to test it, but I'm looking forward to do so. So if I'm taking back my too long didn't read list of all the good things of Apache Pulsar, I think the most important one is the fact that you can now use more ecosystems with it. So if you are using and installing Apache Pulsar on your side, you will be able to use Pulsar ecosystem, but also the Kafka ecosystem and the RabbitMQ ecosystem. And I think for me personally, this is one of the biggest reasons that you should just try Apache Pulsar. And that's it. So thank you for listening me. I will take the questions now. If there is any, I think there is questions here. Great overview, thank you. Are the slides of the talks available? Yes, they are available on my website. Let me just raise here. So my pierrezemb.fr. Is Alibaba planning to migrate array from RabbitMQ in favor of Apache Pulsar? I don't know. I'm not working at Alibaba.
Sorry, I think that was from the previous session. You do have a question that came in at 10:05. If you see that one.
Do you need the Kafka-proxy? Do you need the Kafka-proxy component if all the streams, producers, and consumers are on the same virtual private network? Yeah, so that's a good question. One of the things is that we really wanted to avoid exposing the broker directly. And this is the main reason that we are using this. And this is offering like an entry point to our infrastructure, and there is a lot of metrics that can be collected on the Pulsar proxy, so you have deep insights on the traffic on the top of your cluster. So it's not needed, but we are really happy to have this proxy.
Great. We actually, there's another one. I'm going to add it in the chat.
Okay.
That came in. I can't add in the Q&A since I'm a host.
It's on the chat?
Yes.
Can you just read it?
Yes, it is. Did you use Pulsar CTL for the control plane?
Yeah.
Pulsar control, sorry.
Yeah, that's a good question. We started the project before the Go library. So that's another lesson, I guess. We could have done this. But yes, we are thinking about moving to Pulsar CTL. So Pulsar CTL is a Go library that is wrapping the admin part of Pulsar. And we ended up writing our own library because we like to rewrite stuff, I guess. Other questions?
Let me see.
I think I'm just right on time.
You are right on time. You are great.
Perfect.
If anyone has a question, you guys have about 2 minutes to ask it. Otherwise, we want to say thank you. Thank you, Pierre, for a great presentation. Very much enjoyed it.
Yeah, feel free to ask them on the QA part. Yeah.
Okay, great. Well, it looks like, sorry,
one
did you
question.
Get one?
Did you run into other Bookkeeper issues? No, the only Bookkeeper issue we had was the one that I showed, that when we just fill up all our Bookkeeper machines, so the whole cluster went dark. But after that, we try to do some chaos monkey engineering. So just plug out the Bookkeeper. It was really robust, and we did not saw any repercussion on messing around with Bookkeeper a lot. So that was, I think, Bookkeeper is really solid for this use case of streaming. I hope I answered the questions.
I'm just seeing if there's a follow-up, but otherwise. I think we are good. Okay, great. Well, thank you again, Pierre, for a great
Thank you.
session. You guys know where to reach out to him with any follow-ups. But with that, I'll say thank you, and I'm going to go ahead and take over the screen.
Yeah. Bye-bye. Have a nice day.
Thank you. Bye.
Thank you.
Okay, great. So for everyone on the line right now, thank you so much for joining. Really excited to have you here. We have just about 10 minutes until our next session joins. So just a quick note, there was a link somewhere that did not have the correct number to join track 3. So I did add that in the chat box. If you guys have any questions, the link should be updated now, but in case you bookmarked it earlier, track 3 has been running, but there was just one number missing. So check the chat. It's also been added to the Pulsar Summit Slack channel. So thank you